the method of storage. What is the importance of Frederick-Kraft reaction? Now, right, Frederick-Kraft reaction are divided into two. We have the Frederick-Kraft alkylation, and then we have the Frederick-Kraft acylation. Now, Frederick-Kraft reaction is important in organic synthesis, all right, because it aids in the introduction of alkyl and acyl group on aromatic ring, especially. Does not mean that we can't have it in other ring, but aromatic ring especially. That's why we say Frederick-Kraft reactions are classified into two: alkylation and acylation. The Frederick-Kraft reaction is a reaction that can aid in the introduction of alkyl group or acyl group to an aromatic ring. It involves the use of such catalyst known as the Lewis acid catalyst. Lewis acid catalyst, which are aluminium trichloride, etc. All right, aluminium trichloride, etc. Especially this aluminium trichloride is the most important catalyst that is used in Frederick-Kraft reaction. Now, for the alkylation, you may decide to write this. Let's say this is a structure of benzene. Now, what Frederick-Kraft reaction we actually do is you have an alkyl halide. Alkyl halide represented with arrow X, then in the presence of this catalyst here. All right. Now, at the end of the day, what do you think you are going to form? This will react with this, and this is going to form a compound like this. The benzene ring will still remain intact, but then the alkyl group will attach, and this is benzene and this is alkyl benzene. This here is an alkyl halide, and this here is your catalyst. So you see that the Frederick-Kraft reaction have been able, or it aids us to add alkyl group to benzene ring. So for instance, we want to add, let's say, CH3 to this, or let's say CH3CH2 to this compound, to benzene ring. You want to form ethyl benzene. All you need to do is to find a suitable alkyl halide you are going to use. This case now is you say you want to impute ethyl group, so here will be CH3 CH2 and then you put Cl. This ethyl halide. What we are concerned about is the alkyl group that is present there, so that at the end of the day, the product of this reaction will be something like this: CH2CH3, which is ethyl benzene. Do you understand the process? So that is for alkylation. Now, it also aids in the addition of acyl group to aromatic ring. What is acyl group? Acyl group is something like this. You add it to aromatic ring. Why this other one is alkyl group to aromatic ring? This is an acyl group. For instance, if you want to add something like, you want to form a ketone like this with this aromatic ring, you can use Frederick-Kraft acylation to add this group here to this. For instance, you want to form benzophenone. All right. How do you achieve that? You use either an alkanoid halide in the sense that you just put halogen as part of this acyl group. You put halogen, become alkanoid halide, or you use acid anhydride. Acid anhydride is something like this. All right, it's either you use this alkanoid halide or use acid anhydride. Is that okay? So what actually happens is you have the benzene ring, which I'm going to draw here, plus or passing through, you have arrow C double bond O X, and then this is also aluminum chloride. Now you see that in all cases we've been working with, it always involves the removal of the X. So this will give us something like this. Remove the X and then attach the carbon to this side. So here becomes C double bond O arrow. You've actually formed what functional group here? What functional group do you think this is? What functional group do you think this is? Now this here is a ketone. So you literally form a ketone. So for instance, if you want to form benzophenone, this is benzene ring. Benzophenone, the final product for benzo, or the structure of benzophenone, is something like the C double bond O, and then you have CH3. So it means you add an alkanoic chloride that has CH3, C double bond O, with a halogen. So this will be something like the CH3, C double bond O, let's say chloride, which is like ethanol chloride, and aluminium trichloride. So you add it here. This reaction is what we call the Friedrich-Crafts acylation. So you see how you can actually answer this question. You tell them that the Friedrich-Crafts reaction is an important reaction in organic synthesis that aids the addition of alkyl group and acyl group to aromatic ring. It involves the use of Lewis acid catalyst. It is an example of aromatic substitution reaction where the hydrogen atom will be removed and appropriate alkyl group or acyl group will be substituted into the benzene ring. Please take note of this statement that it is an aromatic substitution, electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. And then you write all these little equations to express what you are trying to say. Then you get your full mark. All right, so that is that. That reaction is used in the assay of benzocaine. Now we said benzocaine is a base. Now they can be quantitatively estimated as their free base or hydrochloride. Hydrochloride in the sense that in the salt form by what? Sodium nitrite titration method with endpoint determined amperometrically. We are taught amperometry, right? Ampere current in year 3, I think year 3 second semester. So the endpoint can be determined amperometrically. Now lidocaine can, okay, they ask for benzocaine, but I just put lidocaine. Lidocaine can be assayed as a free base or hydrochloride by non-aqueous titration using perchloric acid as titrant and crystal violet as what? Indicator. So that is the method of assay of benzocaine. It can be quantitatively assayed as their free base or the salt form, which is hydrochloride, by sodium nitrate titration. Sodium nitrite. Please note that there's a difference between sodium nitrate and nitrite. Sodium nitrite is something like this. Sodium nitrite titration method with the endpoint determined amperometrically. Alright, that is that. Now draw the structure of benzoic acid and parabenzoic acid. This one is something that is very easy. So when they say draw the structure of benzoic acid, this is how it look like. And then draw the structure of parabenzoic acid. This is how para-amino benzoic acid. This benzoic acid, para means at the para position, which is somewhere around here you have amino group. So this first one here is your benzoic acid. Alright, why this one here is para-amino benzoic acid. Alright, that's that. Now, outline the synthesis of benzocaine. Now, the synthesis of benzocaine is very simple. Starting with what? They may decide to say start from benzene. You can actually start from benzene to synthesize benzocaine, right? How do you start from benzene? Start from benzene. I want you to start from benzene. In the note they gave you, start from toluene. But you can actually start from benzene because they may decide to just want to trick you and they say start from benzene. Alright? There's no harm in trying. So starting with benzene, you have your benzene ring, which is something like this. So first of all, we need to get toluene. And for us to get toluene is something like this, which is CH3. This is where they started in the material. But I've told you just now that you can add alkyl group, right? Like what I did here, to benzene ring by Frederick-Kraft alkylation. So they may want to test your understanding of Frederick-Kraft alkylation. So what you just do is you put something like CH3Cl here, then you put aluminium trichloride as a catalyst. It gives you toluene, which is something like this. Alright, believe that is the right. So this will give us toluene. The CH3 can be anywhere, it can be on top here. Alright, because that is the first substituent you are adding. So this is now the structure of toluene. Alright, now when this toluene is oxidized with a powerful oxidizing agent, the toluene will give us carboxylic acid. Alright, when this toluene is oxidized with powerful oxidizing agent, it's going to give us a carboxylic acid. This same group here, you know it has been oxidized to carboxylic acid. This same toluene, it can undergo nitration reaction. Now, what is nitration reaction? Nitration reaction is a reaction that involves the addition of nitrite to aromatic ring. It usually involves the mixture of two things, HNO3 and H2SO4. When HNO3 and H2SO4 mix, they are going to form this nitrite ion. Are you getting it now? This nitrite ion now will come to this place via aromatic substitution reaction. So we are expected to form NO2 under here too. So we have NO2. So that is the product that we are going to form here. So the product here will be 4-nitrobenzoic acid. Alright, so here you have 4-nitrobenzoic acid. It's kind of very cheap, right? Exactly. Now that you've gotten 4-nitrobenzoic acid, my dear student, what is the next thing you can do? You want to change this 4-nitrobenzoic acid to an amine group. You want to change this NO2 here to amine. Now, the easiest way to change NO2 to amine is to react the amine with something like tin in HCl. This tin in HCl will act as a reducing agent and reduce this NO2 to the corresponding amine. So this NO2 will be reduced to amine, and that will give us something like this. Because you need to have what you want to synthesize in mind. The structure you want to synthesize is something like this. That is one thing with organic synthesis. In organic synthesis, always have what you want to synthesize in mind. That will direct you. When you know your destination, it is very easy for you to find a clear path to that destination. Is that okay? So this reagent here will reduce this NO2 to NH2. So you have the amine group here. So you've got to your amine. Are you getting it? Aminobenzoic acid. However, you are not done yet. You need to convert this carboxylic acid to ester. Now, my dear student, how do you convert carboxylic acid to esters? Now, it's by reacting with ethanol. It's by reacting with what? With ethanol in the presence of H2SO4. So when you react this with ethanol, water will be eliminated. True or false? If you know your chemistry very well, this is like plus HO C2H5. Water will be eliminated, and then the final product will be your benzocaine. So this will be COOC2, because you are removing this hydrogen. You are removing this hydrogen and this OH. You have COOC2H5. Alright, so here will be C2H5, and here will be NH2. So that is the product of this reaction. Do you understand that? And this is your ethyl 4-amino benzoic acid, which is also called benzocaine. So this is how you synthesize your benzocaine. Is that okay? Exactly. Now that you synthesize benzocaine, the next question we are looking at it: draw the structure of tetracaine and comment on its SAR. Now tetracaine is more like is an ester 2, so it follows more like procaine, but the differences between tetracaine and procaine, I'm going to spell it out. Tetracaine is more like the structure of procaine, but the difference is because they change this H2 here to butyl group, and then this C2H5 is now CH3. It's more like procaine. So if we draw the structure, you are going to have, normally procaine is something like this. So let's draw the structure of procaine. From there, we'll be able to modify the structure to get your tetracaine. We say procaine is something like this: CH2, CH2N, C2H5, C2H5. You don't need to memorize, just link the ideas together. For tetra, the reason why they call it tetra is because it's having 4 carbons at this nitrogen here, tetra 4. So this group here we change to C for H9. So I'm going to put H9 here, C4. So this gives us C for H9, and then change this group here from C2H3 to CH3. So once you know how to draw procaine, it will be very easy for you to draw tetracaine. Alright, now what is the SAR of tetracaine? Now when you add this butyl group, you see it's more like from procaine. When you add the addition of this group here, that is removal of 2 hydrogen, and adding this butyl group, causes increase in partition coefficient of the drug, increase in local anesthetic activity, decreased onset of action, and lastly, increase in duration of action. Alright, so that is that for these questions from Dr. Owaba. Thank you very much for your time. Alright, we'll see in the next one. Bye bye. So just try every morning when you wake up from now to the end of the exam, try and learn these structures. They are very, very important, and try and practice these things very well, because there are a tendency that this is what will come out again at his own on his own path. All right, thank you.